Good morning guys, welcome to DUALITY Academy tutorial. Thanks for watching our videos online. Please, if you are not yet subscribed, please do want to press the subscribe button and the notification bell in order to see all of our educative videos online. Thanks for watching once again. Please remember to share this video, like and drop your comment. Thank you and God bless you. Amen. Today I will be considering a topic under physics known as what? The wave-particle duality of a matter. The wave-particle duality of what? Of a matter, specifically light and what? And atomic particles. I'm talking about light wave. A light wave is an electromagnetic wave in which it requires what? No material medium for its what? Propagation. Light waves are electromagnetic wave where there is no material what medium for what? Propagation. What do I mean by that? Meaning that what? Light travels without what? Without a material medium. Now, this light has been confirmed to be a wave because it exhibits some characteristics such as what? Inference, diffraction, and what? And polymerization. Even though light waves is a what? Even though light waves is an electromagnetic wave, it also possesses some qualities of what? Of particles. And that's what we're talking about today. That is, wave also sometimes behave or possess a what? A particle-like what? Nature. Light possess a what? A particle-like what? Nature. Light possess a particle-like what? Nature, which we are about to study today. So discover that the energy of electromagnetic wave of light is what? Is being quantized in form of particle-like what? Packages called photons. Now, the what? The light waves, that is the energy of the electromagnetic wave, which is known as what? Light waves, is being quantized in form of particle-like what? Energy called what? Photons. Meaning that when light behave as a particles, they are called what? Photons. When light behave as what? Particles, they are called what? Photons. So light behaving as what? Light behaving as particles is known as what? Photons. When light behaves as particle is known as photons. And based on this, Einstein postulates what? A law concerning what? Photon. Einstein's law. Einstein law of what? Of photons. There is a law that Einstein postulates based on this what? These characteristics of what? Of light. When they possess what? When they behave like what? A particle. He said that what? A beam of light consists of small packages of what? Energy. A beam of light consists of what? Small packages of what? Energy called quanta. He stated that what? Einstein's law stated that what? A beam of light consists of what? Of small packages of energy called quanta or photons. And this what? This energy of individual what? Photons is directly proportional. He said that this what? The energy of individual photon is directly proportional to what? To the frequency, given that what? E is equal to what? HF, where H is the what? Is the Planck constant. So Einstein's law of what? Of photon states that what? The energy of individual photons of light is directly proportional to the what? To the frequency of the what? Of the radiations of light. So given that what? H is equal to what? It's just the constant of proportionality. Given that what? H is equal to what? Constant of proportionality, known as what? Planck's law. Meaning that what? The Einstein's law of photon is an extension of what? Planck constant. Now, so knowing fully well that Einstein's law is equal to what? E, that is energy of the photon, is equal to what? HF, where F can be given as what? C over what? Lambda. Now, E is equal to HF, where F is equal to what? C over lambda. Meaning that what? The frequency of what? Of a photon is equal to what? The speed of light over wavelength, where E is the what? Energy of what? Of a photon. Energy of a photon measured in what? In joules. In what? In joules. So H is what? Is the Planck constant of value 6.6 times 10 raised to power minus what? 34 joules. While F is what? Is the frequency. Is the frequency of the what? Of the photon. The frequency of the photon. F measured in what? Measured in Hertz. So and lambda is known as what? The wave what? The wave length in what? In meter. So this is what? This is the formula for what? For energy of quanta, that is photon, postulated by what? Einstein. And substituting this what? Hc over lambda for F, the equation becomes what? Hc over what? Lambda. When you put C over lambda for F, we have Hc over what? Over lambda, which is what? The wavelength of the what? Of the photon. So this is what Einstein postulated about what? About energy of a photon. He postulated that what? The energy of a photon is proportional to the frequency of the what? Of the photon. And also he said that what? Even though light behaves as what? As particle, the photon has what? Zero mass. Even though what? Light behave as what? As particle known as what? Even though light behave as particle known as photons. Photons has zero what? Zero rest mass. So it means that what? Photon has no mass. So he postulated that what? The momentum of what? Of a photon is given as what? So therefore the momentum of a photon is given as E is equal to what? PC. So from here now we can make P equal to what? E over C, where our P is the momentum, where P is the what? The momentum, and C is the what? Is the speed of what? Light. Speed of light. Is the speed of light, and the value of the speed of light is given as what? 3.0 times 10 raised to power 8 meters per second. So the speed of light is given as 3.0 times 10 raised to power 8 meters per second. And what? E is the energy of the photon. So this is what? Light behaving as what? As particle for you. Also, one of the phenomena that give insight to how light behave as particle is what we know as what? Photoelectric effect. Photoelectric effect give an insight to how what? Light behave as what? As particles. What do you mean by what? Photoelectric what? Effect. What do you mean by photoelectric what? Effect? Now, considering the diagram what? Below. Considering the diagram what? Considering the diagram of a metal surface below. Now, considering the diagram of a metal surface below, now assuming we have a what? A metal that is what? In the metal we have what? The positive charge. We have the positive charge, and in between this positive charge we have our electrons. We have our electrons in between this what? positive charge, we have our what? Electrons. Now, this is a metal surface having what? A positive charge and what? And the electrons. So now, and we have this is the metal surface. Now, in this what? In this surface of what? Of metal, when a light strike this metal surface, when a ray of light, when light strike the what? The metal surface, indicated by the what? By the arrow. This is what we call what? An incident what? An incident light ray. I think that when a light strike the metal surface, it strikes in such a way that these electrons absorb what? They absorb what? Light energy. Now, when a light strikes the metal surface, the electron absorb what? Absorb enough energy to detach itself from all other what? Positive ions that wanted to keep it in what? In the material medium. Now, when the light strikes the what? The metal surface, the electron absorb enough energy from the light to liberate himself from this what? From this relationship with positive what? Charged ions. And as it gains more energy, it overcomes the attraction between the positive charge and the what? And the electron. So this electron now escaped the what? The metal surface as a result of the energy what? Absorbed from the incident. So we have the what? The electrons flowing out. So here we have the work function, that is the amount of energy required for what? For electron to be what? To be ejected from the surface. Now, the work function here, which is denoted by W, is the energy that is required to liberate the what? The electrons from the what? From the metal surface. That is, the work function is the energy responsible for keeping the what? The electrons in the metal surface intact. But when the electron absorbs enough energy that is more than what? This work function, then it is liberated from the what? Metal surface. So this is the incident light, and this is the work function that keeps the what? The electrons within the surface. And as it absorbs more energy from the incident light, then these electrons escape from the what? From the surface of the metals to become photoelectrons. To become photoelectrons. So based on this phenomenon, we have series of what? Formulas, because photoelectron involve incident light, work functions, and the what? The energy of the what? Of the photoelectrons. We have the energy of the what? Photoelectrons, which is known as what? K max. Because when an energy strikes a metal surface, the electrons absorb enough energy to liberate himself from the surface in order to become what? Photoelectrons. So mathematically now, the photoelectric effect can be expressed as well. Mathematically, the equation of a photoelectric effect can be expressed as follows. Now, we now have what? We now have what? K max, which is the what? The energy, the K max, which is the maximum kinetic energy of what? Of the photons. That is the maximum kinetic energy of the what? Of the photons equal to the what? The energy of the what? Of the incident light. We call this one energy of the incident light, which is what? EI minus what? The work function. The work function. Note that the work function is the minimum amount of energy required to liberate this what? This electron from its what? From its metal surface. Required to eject what? The electron from the metal surface. So now using what? Now replacing this what? This formula with what? Is seen as what? As postulated he said that what the energy of the photons, that is the light, is equal to what? HF. So we have what? E K max equal to what? Equal to HF minus what? W what? Naught minus W net. So we can furthermore and say that our E mass is given as what? Our E mass, which is what? Is given as EV naught, and our W naught is equal to what? HF naught, where F naught is the minimum frequency required for the what? For the electron to be ejected, while the frequency F naught, which is known as what? The threshold frequency, is the minimum frequency required for an electron to be ejected from its what? From its surface, and EV naught, this is electron volts. We call them electron volts. This is what? The electron, and this one we call it what? The stopping potential. It's also known as what? It can also be given as what? As E max in our equation. So therefore, the equation becomes what? EV naught equal to HF minus HF naught, where E is the electron which has a value of what? This electron has a value of what? 1.26 times 10 to the power minus what? Minus 19 what? Joule. We call it what? Electron volts. Electron what? EV is what? Electron volts, which is given to us what? 1.6 times 10 to the power minus 19 what? Joule. And V naught is the stopping what? The stopping potential. V naught is the stopping potential. The F naught is what? Is the threshold what? Threshold frequency. This threshold what? Frequency. And what? H is what? The mass what? The mass Planck what? Constant. The mass Planck constant. So these are the formula that we are going to be using in solving what? In solving the problems under what? Photoelectric what? Effect and other related what? Topics on wave particle duality of what? Of a matter. Also, before we go, we have to talk about what? The particle also behaving like a light wave, or a particle behaving as a wave. I will talk about what? Light behaving as what? As a particle. Also, atomic particles also behave like what? Like wave. Particles also behave like wave. Now, based on what? De Broglie what? Postulate. De Broglie states that a free particle of rest mass m moving with a what? A non-relativistic what? Velocity has a momentum which is related to it what? To wavelength with a formula lambda equal to what? H over what? Over the momentum. Now, this is what we call what? De Broglie what? De Broglie what? Postulates. Now, this is atomic what? Particles behaving as what? Particles behaving as what? Particle behaving as wave. Now, the what? De Broglie what? Postulated that what? A particle with a rest mass what? M. A particle with what? With a rest mass M moving with a what? A non-relativistic what? Velocity. Have what? Have a wavelength that's related to what? To the momentum of that particle using the formula lambda equal to H all over what? All over momentum. Meaning that what? Now, lambda is equal to H all over what? mv, where mv is your what? Is your momentum. Where mv is your what? Momentum p. That is momentum what? Momentum. So where mv is equal to what? P momentum. Now, m is equal to what? The mass of a free particle, and v is the what? Non-relativistic what? Velocity. Non-relativistic relativistic what? Velocity. So that's what De Broglie postulates, and he discovered that what? The particle also behave like a wave by possessing wavelength, which is given as what? H over P. And this P is the what? Momentum, which is given as what? The mass of the particle times what? The velocity of the what? Of the particle. And that's that about what? About what? About particles behaving as what? As wave. Now let's go into what? The questions before us as what? As we talk about what? Wave particle duality of matter. What are the likely questions we are about to what? Meant under this what? Under this topic. Now the first question says that an electron of mass 9.1 times 10 to the power minus 31 kilogram is traveling at a speed of 2.0 times 10 to the power 6 meter per second. Calculate the associated wavelength of the electrons. We are told that this is an electron of mass 9.1 times 10 to the power minus 31 kilogram. Now, this is an electron. An electron is a particle. It's an atomic particle of mass what? Number one question of mass M equals to 9.1 times 10 to the power minus 3 kilogram. Now, it's traveling at a speed of 2.0 times 10 to the power what? 6. It's starting at a speed. So the velocity or the speed of the what? Velocity or the speed of the electron what? Is what? V equals what? 2.0 times 10 to the power minus 6 meter per second. So that's the velocity at which what the electron is traveling. That is equal to 2.0 times 10 to the power minus what? 6. And that's a calculate the associated wavelength of the electrons. Now, it's exhibiting a light particles. That's why it's exhibiting a light wave, that is an electromagnetic wave. That's why we're asked to calculate what? A wavelength, the wavelength of the electron. So how do you calculate the wavelength of the electron? So we are looking for the wavelength, which is what? Unknown. Now, remember what de Broglie postulated about what? About a particle behaving as what? As an electromagnetic what? Wave. Now, from this formula that we just what? Written, we have what? Lambda equals what? H over what? mv. That is over momentum. So lambda is equal to H over what? mv. And we have to calculate what? The wavelength. So the lambda simply means what? 6.6 times 10 to the power minus what? 34, which is the Planck constant. And we are given here all over what? The mass of the electron times 10 to the power minus 31 times what? The velocity 2.0 times 10 to the power minus what? 6. So what do we have? Let's press our calculator. That is open bracket 6.6 times 10 raised to power minus what? 34 bracket close divided by open bracket 9.1 times 10 raised to power minus what? Minus 31 multiplied by 2.0 times 10 raised to power minus what? Minus 6. So what do we have as our answer? We have 3.62 lambda is equal to what? 3.626 times 10 raised to power 5. 1, 2, 3, 4, 5. Times 10 raised to power 5 meter. So approximately what? Lambda is equal to 3.63 times 10 raised to power 5 meter. So that's our answer for number one questions. So as you can see how we did it, we use what? The de Broglie's law, which says what? Lambda is equal to H over what? Momentum, which is equal as what? M what? V. So we should set our value, which is what? The Planck constant, the mass of the electrons, and the what? And the velocity of the what? Electrons. And then to what? Question number 2. Question number 2 says that when light frequency 5.4 times 10 to the power 14 Hz is incident on a metal surface, the maximum energy of the emitted electron is this. Calculate the minimum frequency of radiation for which the electron can be what? Emitted. Note that we are asked to calculate the minimum frequency of what? Radiation. we are told that the light of frequency 5.4 times 10 to the power 14 is incident on a metal surface. This is supposed to be on a metal surface. So the maximum energy of the emitted electron is this. Calculate the minimum frequency of radiation for which the electron can be what? Emitted. Now, this is all on this question is particularly on what? On photoelectric question. It's particularly on photoelectric question. Let me look photoelectric problem. So that is photoelectric what? Problem. Now, how do we go about these questions? We are told that the frequency of the incident what? Light. The frequency of the incident light, I call it what? Fi, is given as what? 5.4 times 10 to the power 14 arcs. So that's the incident of what? That's the frequency of the incident light. Now, the light of frequency 5.4 times 10 to the power 14 is incident on a metal surface. The maximum energy of the emitted electron is this. Now, the K max, the energy what? The maximum what? Kinetic energy of the photoelectrons is given as what? 2.0 times 10 to the power 9 minus 19 what? Joule. Don't forget that in photoelectric emission, we have what? Something like this. And you have a metal surface with what? Positive what? Charge and what? Negative what? And negative charged electrons. So we know this is what? This has a force of attraction. But when there is an incident what? An incident light carrying an energy what? EI strike the what? Metal surface. These electrons will absorb what? They will absorb energy what? It will absorb energy. Now as the incident rates strike the what? Metal surface, the electron will absorb what? Enough energy to escape from the what? From the surface. They now have what? They now become photo what? Electrons, and the energy required for them to become a photoelectrons, the what? The energy that makes them a photoelectron, we call what? EK mass. So we call it what? Maximum kinetic what? Energy, and it's given as 2.0 times 10 to the power minus 19. While the frequency of the incident light is the one given to us here. So now we are now asked to calculate the minimum frequency of radiation. Now, to get the minimum frequency of radiation, we have to get the work function, that is the energy that keep the body in this what? In this material. So W naught, and W naught, which is work function of a metal, is given as LH multiplied by the minimum frequency. The work function that keep the electron in the what? In the metal surface is given as W naught equal to H times the minimum what? Frequency, and that's what we have to calculate. And the relationship between the work function and the K max is given by the photoelectric effect equation. And from using what? Photoelectric effect equation now. Using photoelectric effect equation, we have EK mass is equal to what? EI minus what? W what? Naught. So we have to what? Use what? The maximum kinetic energy of the photon is equal to what? The incident what? Energy minus what? The work function. Now, we can get our what? Incident what? Energy from the what? From the incident what? Frequency. Incident energy can be obtained from what? The incident frequency, which is equal to what? EI is equal to H what? Fi, which is equal to what? 6.6 times 10 to the power what? Minus 34 times, what do you have there? Times 5.4 times 10 to the power 14. So what do you get as our what? Incident energy. Let's get that one. What do you get for our incident energy? So what's our incident energy? We have what? 6.6 times 10 to the power minus what? 34 multiplied by 5.4 times 10 raised to power what? 10 raised to power 14. This one also is 10 raised to power what? 14. 10 raised to power 14. We have what? 6.6 times 10 to the power minus 34 times 5.4 times 10 to the power 14. We're going to have 3.564 times 10 to the power 19 joule. So that's that for the incident what? Energy. Now to calculate now the work function in order to get our what? In order to get our F naught, which is the minimum frequency. Now we can get our work function here from this formula. So having that E max is what? 2.0 times 10 raised to the power minus 19 what? Joule, which is equal to what? The incident energy, which is what we just obtained now, times 10 raised to the power minus what? 93.564 times 10 to the power minus 90 minus W what? Naught. So take this to the other side here and bring this one here. So we have what? W naught equal to 3.564 times 10 raised to the power minus what? 19 minus 2.0 times 10 raised to the power minus what? 19. So we have W naught is equal to what? 3.564 minus times 10 to the power minus 19 minus 2.0 times 10 raised to the power minus what? 19. So we have what? 1.564 times 10 raised to the power minus 19 joule. So these are what? Work function. Now from our work function, we can easily get our what? Frequency, minimum frequency, which is F naught. So therefore W naught is equal to HF naught, given that what? Minimum frequency is equal to W naught all over H. So our minimum frequency now equal to 1.564 times 10 raised to the power minus 19 divided by the Planck constant, which is what? 6.6 times 10 raised to the power minus what? 34. So we have the answer here divided by what? Divided by 6.6 divided by 6.6 multiplied by 10 raised to the power minus what? 34. So what do we have here? We have 2. So the minimum frequency is what? 2.369 times 10 raised to the power 14 Hertz. So that is our frequency. That's our minimum what? Frequency as the question asks for it. Calculate the minimum frequency of radiation. So that's what? The minimum rate of what? Of frequency for the radiation. The minimum frequency of radiation for which the electron can be emitted. So that's that one, question number 2.